Hello everyone, today we're going to solve the groups of spectral equivalent strings. So to solve this problem, first of all we are going to separate the odd position and the even position. For example, for the string A, B, C, we're going to group A and C together and B and together. And then for each of the group, we're gonna sort all the letters alphabetically, and then after sorting, we're gonna group them together by AC plus BD. So instead of sorting by the position, now we're gonna separate them together and group them together without losing any generality. So and then finally, we're gonna check how many position, how many distinct string we're gonna have in our set. So let's say with this example, we're gonna have ABCD and we're gonna have ACBD string for the first one, and for CDAB, we're gonna do the same thing. First of all, we're gonna have CA, B, and after sorting we have A, B, and E, and then we plus them together, sum them up, ACBD. So which means that this string and this string have the same form, same final form. So let's continue with the third one with C B C B A D. We're gonna have uh, CA and short them dot ACD, right? And all of them have the same final form. And for the fourth x, y, z, we're gonna have x, y, and sum them up. We have x, y, z, and finally we have z, z, y, x, and we're gonna have uh, z, y, and x, and we sort them, and we have so we're gonna have oh x, we're gonna have iz x, and for this one we have the z x y x y y. We're gonna have uh, xz iz, then we have yz, which is the same form with the fourth one. So we're gonna have uh, three final form at the end. So that's basically the idea. And then now we're gonna implement it. So for each of the string, we're gonna look through each of the word. For string word string words, we're gonna transform the word into a new form, new final form. So let's say this final form, go to transform the word. We're gonna do the process of separate the odd and even position and sorting and plus sum them up, and we're gonna put all of them into a hash map, or we can use just a set for it. I have an order set, string set. Then we're gonna insert pointer form into our set, and finally we just need to return the new set size. Yeah, that's all for the idea. And most of the thing is depend on our transformation. So first of all, we're gonna separate the odd and the position, the odd and the even position. And then yeah, let's just get thing first. If I 2 equals 0, push me off one, even even position plus with si, and else we're gonna have the odd position with si. Then finally we're gonna sort all of the odd and turn some of them. And the topic for this one, we have a set and string sorting. Actually, you can replace this set by a hash map as well. So we gonna put hash map to this one, and the time complexity gonna be on the first of all we have the number of string, number of words, then because we're gonna sort the position as well, so it's gonna be multiplied with length of each string multiplied with log length of each string. Yeah, and for the space complexity, it's just basically the number of word. Yeah, I think that's all for this question. Yeah, that's all for this question. I hope this helped you guys. Thank you.